So this is what we're doing. We've got these ways of knowing energy, right? Something can be moving, right? So you're going to have 1 FMV squared. It can be on top of a hill, so we can have mgh, right? There could be a spring, right? We could have 1/2 kx squared, right? This would be like my fantasy, right? That there's a spring wound up on a car that's moving on top of a hill, right? And then we give it a push to speed it up, right? Now most of these are going to be 0. In fact, the simple ones we're going to do, it's like one of those will become one of those, or 2 will become 1, or 1 will become 2, or something like that. But it's my wildest fantasy that we would get all these terms fulfilled, right? Okay? And then on the other side, you know, in the after picture, when it goes to something, right, we could also have a spring that's wound up or something like that, right? 1/2 kx squared, whoops, I can't talk. You know, we could, the car could still be moving, but maybe at a different velocity, right? We could have climbed a hill or be on a different elevation, right? And it could be that we have a force times the distance that the energy has gone to. The only tricky thing, these guys are all pretty simple. I mean, if you could read the problem, draw the picture, the spring is either compressed or it's not. You're either moving or you're not. You're either on a hill or you're not, or right? I mean, you're given that about information, right? The force times the distance, the rule for the left side is that it's a force that speeds you up, right? And the rule for this guy, this force here, is one that slows you down. So in the problem where you had the baseball hitting the catcher's mitt, right? The baseball is obviously moving to begin with. They didn't talk about any elevation change, and then they talked about a force and a distance. Clearly the mitt is slowing the ball down, right? So that's what they were hinting at, right? So it's really just a matter of reading the problem and trying to decipher the clues. How about this guy? What do we have going on here? Yeah, it's at the bottom of the hill, it's moving, and is it at height equals 0? No, you could, by the way, argue that is 0 elevation since it's the lowest point, right? So there's really 2 ways to do this one. But one way is to say, no, it's not. If this is 0, it's at 2.15 meters, right? And here it's at a different elevation, right? And then the question asks, what's the speed at the top? Is it likely that it has kinetic energy at the top? It's possible it doesn't even make it up the hill, right? But if it's asking what the speed is at the top, it's either a trick question or, you know, something like that, or if it doesn't make it up the hill. So let's presume it does make it up the hill. So we have 2 things turning into 2 things if we set it up that way. What are they?
Kinetic and potential.
Kinetic and potential turning into kinetic and potential, yeah? Right? So you've got this guy and this guy turning into this guy and this guy. So go ahead and set up your equation, solve it for, what is it, the V that we don't know, right? Now, once you're done with that, or even before you're done with that, right, if you see another way to set it up, you can actually set this up as KE equals PE plus KE. It can be done. You just have to use a different height, don't you? Can't you just use the height of this hill? Yeah? Yeah? I know that you're all talented and gifted, so you could. Yeah?